All right, guys, let's go ahead and continue with domain 2.5 mitigation technique to secure our enterprise. So now we're going to touch on something called configuration enforcement. So configuration enforcement ensures that systems and software adhere to defined security policies and baseline standards. What we're talking about here is just as an enterprise, as a SOC, as a team, we want to ensure that we have some sort of framework or guideline that we go by to harden our devices and to create that configuration, that baseline, right? Whether this is how we name our devices, host names for network devices, the bit key length we use for SSH, it could be any one of those things. It's just our hardening guidelines, and we have to ensure that we enforce it. So when we have big enterprises with a lot of different devices interacting, like Internet of Things devices, we could have ICS controls. Doing configuration enforcement 100% across the board can sometimes be hard. The reason being is that if we have a baseline that says we must use AES 256 as our encryption, maybe those IoT devices don't have that. So sometimes we may have to put in like exception to policies with our configuration enforcement, but we want to try our best to pretty much have a singular baseline that we go off of as an entire enterprise. Decommissioning. So decommissioning is the process of securely removing and disposing of hardware, software, data, ensuring that it can't be misused or compromised. So let's talk about just the hardware first, right? We're talking hardware, and we're trying to decommission the hardware that we've used for our IT systems. Essentially, what we're looking at is how do we destroy the storage and compute components properly? Because sometimes they say things can be stuck in memory sometimes, right? Not too worried about that. Really, we're worried about how we decommission our hardware and our storage. So depending, and I'm going to say this, if you're going to be like, who uses that still? But tapes. Yes, some financial organizations still use tapes to store financial information, like big banks, okay? We have hard disk drives, solid state drives, our optical drives. So if we have CDs or DVDs that we have to decommission, or USB drives, how do we make sure that, one, if we're trying to destroy them, how are they not recoverable? And two, if we're just decommissioning to archive them, how do we safely and securely archive? So when it comes to destruction with hard drives, you have something that you can do called degaussing. That's magnetic wipes, right? That gets rid of the information. This does not work for solid state drives. For solid state drives, you want to do something like shredding to destroy them properly. Now it comes with software. So with software, it's kind of, if something lived on a hard drive, if we had an application on-prem that lived in this storage, well, when we destroy the hardware, it kind of gets rid of the software, right? But where are our databases stored at? How do we destroy them properly? And that's going to get into just your destruction policy, okay? If we're destroying it, like deleting the database, dropping the database, is there still remnants on there? And if there is, then that kind of leads us into what, guys? The physical destruction, okay? Now, what if we have information in the cloud? Well, then it's really just on the CSP, right? If we delete our information from the cloud, is there still remnants in that cloud data center on the actual physical disk that it's sitting? Possibly, right? But that's kind of the agreement you make with the cloud service provider when you don't actually own the hardware and you're just renting services or servers or serverless architecture like databases, okay? That you're not managing the operating system. And then, of course, we have hardening techniques, something we've been talking about a lot in this course. So when we harden our devices, we want to make sure we're doing this so we give ourselves a good defense, in-depth approach. And we're going to start with the basics, right? Essentially, what we want to do is just reduce our attack surface. So we kind of, just like the principle of least privilege with identity access management and roles and permissions, I like to take the same approach into hardening our OSs and our devices and our IoT devices and really anything on the enterprise. If we don't need it, delete it, right? If we don't need this port open, filter it, close it. If we don't need this service, don't let it start on startup, right? Like Microsoft, like Windows features and services, right? We want to minimize all the potential attack vectors by disabling unnecessary service, ports, and features. We want to make sure that this hardening is also done in our baselines, right? So kind of goes hand in hand with configuration enforcement. When we have a standard image that we may use for all Windows 11 clients, we want to make sure that they're hardened. And then we can even get more granular. We can say that, hey, if you're in the research and development section, if you're in accounting or sales section, we may want to have a Windows 11 image specific to you with third-party apps installed and services disabled, okay? So hardening can be very simple or it can be very complex depending on the size and the architecture of your enterprise. And this should be an ongoing process. We want to make sure as we introduce more applications, more things into our enterprise, we regularly review our hardening techniques. Installation of endpoint protection. So we have a couple different things we're going to talk about here. So we have EDR, XDR, we have MDR, and then we also have things like DLP, antivirus, anti-malware, and then host-based intrusion detection, prevention, and firewalls. And then, of course, we just have allow list that can be configured locally on the machine, which is kind of going over like the host-based firewalls, right? So we want to make sure that in our defense in-depth approach, I'm going to keep writing this out for you. In our defense in-depth approach, we're also taking into account our endpoint protection. This could be installing an array of different software that's going to have us meet our security goals, okay? So we have EDR, endpoint detection and response. This is going to allow us to remediate certain vulnerabilities as they happen on our devices. What we mean by that, it's endpoint detection response. So it's going to give us the ability to automatically remediate, run runbooks and playbooks that can isolate or contain potential exploits and also alert us. We have XDR, extended detection and response. This essentially does EDR, but instead of it only being on the endpoint, it's included in the whole architecture, in the cloud, on our network infrastructure, and it's taken into account all the devices, okay? Instead of it just being like a single agent installed on a single endpoint. We have DLP, data loss prevention. That can also be installed on the actual endpoints to stop data exfiltration, to also prevent maybe peripherals from being plugged in, like your USBs. And then, of course, our antivirus, anti-malware suites. That's going to protect us from malware, right? And viruses that could potentially be downloaded and installed, like maybe through a phishing attack. It could also have the ability to contain as well, similar to EDR. And then we have all of our host-based appliances, right? Our host-based detection, our host-based prevention, our host-based firewalls. All these are going to be part of our defense in-depth approach to protect our endpoints. Now, obviously, what we always want to think about here, guys, our CIA triad. If I go and install all these different software suites and protections, could this potentially bog down my device? Could I be using a lot of compute resources for this? Potentially. So we want to start thinking, and when we architecture out our security, is do we want to have client or agent-based endpoint detection or serverless? And we're not talking like serverless architecture, like microservices in the cloud. We're talking pretty much like agentless as well, where maybe we have a centralized server that gives us a single pane of glass that does network connections to do our XDR or our DLP, okay? Just all depends. Okay, so host-based firewalls, pretty simple here. Host-based firewalls can do a bunch of different things, but the primary purpose is to just filter network traffic from the host, okay? Instead of it filtering on the network in line on the enterprise, this is from the host, from the endpoint. This can also help us do intrusion prevention and detection. And when you're getting into the weeds, right? You're like, oh, I have a host-based firewall, but it can also do detection and alert me. You kind of get confused on the wording, right? Yes, a host-based firewall can do detection and prevention, but when we're looking at it from the exam perspective, the primary purpose, right, is to monitor our network and maybe go a step deeper into our application traffic and then allow or deny, okay? That's pretty much it as the primary purpose. Yes, it may be able to alert us, Yes, there may be certain applications like McAfee's host-based firewalls that does IPS and IDS. Primary purpose, guys, to filter network-based traffic. Okay, and then our host-based intrusion prevention system. So kind of showing you that, right? Kind of how it can be like blurred lines with this. So HIPS is a security solution that monitors and analyzes system activities for malicious behavior, taking action to prevent intrusions. So HIDS and HIPS kind of goes a step further. And what we're talking about here is that in contrast to the firewall that just looks at layer 3, layer 4, potentially application like traffic, kind of transit traffic, what a HIPS can do is it can actually monitor your system's behavior, look for anomalies, and then take action to either like quarantine, contain, or delete a malicious threat. Okay. So this can help you also with like virus and malware threats. It could also help you with like data exfiltration. Okay, some more hardening techniques. So disabling ports and protocols, pretty simple here, right? You can do this in a firewall, or you can do this based off services as well. This is going to help us reduce the attack surface by disabling ports and protocols that are not needed, especially in our servers, right? Like web servers. Default password changes. So like I've talked about in this course, when you leave the default credentials, you can easily look them up online, right? You can even do it per model. Obviously, vendors have fixed this a little bit. Like you can have the same model or router as your neighbor, like if it's just from the ISP, you'll probably have a different password, but not always, right? It's best that we just, as we introduce IoT devices, as we introduce real-time operating system, embedded systems that may have weak defaults that can be easily discoverable, we want to make sure we change them, right? Just change them. Make sure you change the default passwords and that they align with your password policies. Removal of unnecessary software. So this involves uninstalling software that is not needed for the business operation. So we're just saying, hey, kind of taking on that concept of least privilege with IAM. Do this for software too. We disable unused ports and protocols, disable unused software.